No, thank you, sir.
Okay, just different field. So solid liquid gas. I'll try to point 4. Then after that we will discuss a few more questions after model 4 because those are the ones that are more slightly different. 4 is actually still same as what we did before. Actually it's not the same one as what we did in the. So we will just look at model 4 first.
Ako, siyam. Saan ka mag-ingat sa maximum pagkain? Sumulit mo yun. Yeah, potong wila.
Ultimate analysis of the petrol. We have 85.5%
I need it for real.
carbon and 14.5% pitch. Okay, so ultimate analysis means that this will be the MF, the mass fraction. So for C, you get 85.5%, then MF for H, you get 14.5%. So as usual here, we assume, so let's assume 1 kg or 100 kg, whichever that you prefer, of fuel. So if we have 1 kg of fuel, which means, so the first thing you need to find here is the number of mole. Right? So the number of mole of the C will be 0.855. Then number of kg in this case will be 0.145 divided by 1. So you get 0.145, here you get 0.0715. Then you use this to construct the equation. So equation 1 asks for stoichiometric energy ratio, so nothing special here. So we use 0.07125 C plus 0.145 H and plus A, so ATH for A. O2 plus 73.76 N2, and the product you get CO2, H2O, and N2. So if you balance this, O and N2, you should get x equals to 0.07125, y equals to 0.0725, and you get ATH equals to 0.1075, and then W you get 0.4042. And balance this, you should get this.
Carbon. Oh, 12是这边来，1.85。
So from here then air fuel ratio. So in this case, air fuel ratio is simply ATH 4.76 29. So divided by 1, you should get 14.34 kg and over 1 kg
哪里 ？NH 啊？你看啊 ，hexane 跟 monomer 其实是不是它不是 hexane 啊？那 hydrogen H2 它的 monomer 是2，所以你除2的话是1。哪里？amount of A over a part of fuel 嘛 ，fuel 是100%嘛，对吧？100%不是1啊 fraction。哎，对啊，问啊，哦。你明明懂了，你还问我，你还笑我。哦，OK。我们两个看起来这样伪哦。Y H2 O 加 W
不是那个猫，
不是我 send 的，
他脸臭了。
这样。
遇到他一直懒啊。
是卡顿还是真的吗？
真的吗？有些过了，我记得有些。
哦，
不然就是在 IG，我记得。
就在一起。
So there shouldn't be any too much issue here. And 2 and 3 also basically just come straight from the sample as well. And you are still given the mixture strength, so the mixture strength is obviously fluid. Since that's what the question used, which is
放个 lock button 那边做什么？你放在这边做什么？
you need to find the air fuel ratio when mixture strength is 0.9. So if the air fuel ratio for the stoichiometric is this, and over the actual is 0.9, meaning if you want the actual one, you just so the actual one is basically just
我记得有一次你不打汉我都没有放。那个他是用不热。
Then the other one just do the same thing. So this one you have excess air, or the bottom one you get efficiency of air.
notification 的 sound。
What?
Alright, so 4 starts for the analysis of the dry product for 2 and 3. So you basically need to solve both of them. Solve both of them and then analyze the dry product for each of them. So here, yeah, the dry product. So 4 for 2, whereby your air fuel ratio is 16.541. From here, you can figure out that 18A coiling at each correct. The A here will be 11.14 based on this. Okay, so if you calculate this and based on this ratio, you can actually just use ATH. The amount of A, okay? You can just use ATH divided by 0.9, it's the same thing. So you will be getting 0.94. So from this, then you can rewrite the
想不起。
and then O2 plus 3.76 and 2. So this is a case of excess air. So then you will get 7.125 CO2. So this one will be 0.07125 CO2 plus 0.0725 H2O, and you will get excess oxygen, and then nitrogen. So these two. So let's say this is so O2 is basically just the new air minus the theoretical one, while N2 is just 3.76, 3.76 multiplied by the amount of air. So I'm just writing out the equation for you. I think the dry product you know how to find out, right? You want to just give it to try. And then if we go through the second one, so the second one will get this. So the A in this case is 88 over 1.2. The amount of air that you get is 8.958. So this case, you get a deficiency of air. So I said, if the deficiency of air case you are not given any product, then you just assume that you have CO and
哦，做透咗，用得刮痧咁啊。
So here, this round, CO2 we don't know, H2O will still be the same. But then we don't know CO, and
Sorry, yeah.
this N2K. So this case then we need to balance.
我也是。
So based on this, so you have two equations for A and B. Based on this, you will get 3.541 B. So like in this case, you can see that it's not exactly the half, it's just approximate. So again, usually if you get deficiency of A, by right, the product should hold, you should hold the product. Otherwise, it should always be just like this, then it's also approximately half. Okay, so based on these two products, you can try to solve for the analysis, for the dry product analysis. So dry product analysis pretty much means that you are looking for the mole fraction, but you don't consider the H2O. Divide one is heavy ratio.
看你第三名。
What did I write here? What did I write there? What? Huh? What did I write at the 16.5 and 12.4? What did I write at the 16.5 and 12.4? Before the exam, no, what did I write? Just read the answer out. 16.5 what? 0.5 kg. And what is this? 1. Okay. So this 16.5 is this 16.5. So now you get what is the 1? Yes. Okay, that's the answer. Then the 0.5. The 0.9 is this 0.9. The amount of air and the heavy ratio is basically the same thing. So you can just use back the same method to find what is the amount of air.
可以有光，有光。刚才要不掉一下。
So is mixture strength is stoichiometric over actual. So if you want to find the actual one, then you use stoichiometric to divide by the 90%. So this APH is the stoichiometric, K is actual. So this is the amount of air.
這個0.9跟1.2哪裡來？0.9跟1.2哪裡來？沒有，我看 question。因為剛才沒有那18的 internet 3000塊台幣跟你一樣。啊，那 iPad 我是在哪裡一片的？ 是啊，我沒有想到也是。
So meaning this A should be 0.0.
when 它是这个 condition 之后。
You just assume it doesn't exist. But you use like this, so you use like 0.035 someone, you use like 0.035 before, and you see, but you treat it as. Okay, we will do one time the dry analysis. Okay, since oh wait, this one 3 enough. Never mind. Just do one time. Okay, so let's say we do for this one. So dry analysis basically you treat the H2O as non-existent. So we find the number of mole of product first. So the number of mole for the product would be the total number of mole. 0.034541 plus. So you ignore the water, you pretend that it doesn't exist. So like it is there, but it's just that let's say you cannot detect it. That's how you detect it. And plus 3.76, 0.08958. So this will be the total number of moles. Okay, so you take the CO2 one, the H2O one, and the N2. Sorry, this CO. So there is no H2O in this case. You only have the CO2, CO, and N2. So then when you look for the dry analysis, so Y CO2, so you use 0.03541 over the total. And the Y CO will be 0.3584 over total N. And Y N2 goes to 0.0, hold it up, 0.08958 over total N. So there isn't any water component. So once you found this, just open them up to check whether you get one or not. Clear for this one, for dry analysis. So if you get wet analysis, then you include the water. That's pretty much the only difference. But regardless, when you construct this equation, whether you are doing dry or wet analysis, you must have water there. It's just that when you analyze dry or wet, only then will be no water. So one thing that you can watch out for here also is whenever you find mole fraction, one is the mole fraction, right, dry or wet analysis, usually only N2 will have the most percentage. So N2 will have like 80%, the rest is all a few percent. So if one of them is off, then most likely you need something wrong with the result. I accidentally wrote less 1 0. Okay, we look at the final section now. So, part 5 asks for the volume flow rate of the product through the heat exhaust per unit rate of fuel consumption for 3 when the pressure is 1,113 bar and temperature is 110 degrees Celsius, assume 1 bar is 100 Pascal. So this one, pretty much the answer is there for you. You need to find the flow rate, volume flow rate of the products for every unit rate of fuel consumption. So, from the start, we already assume that we are using 1 kilogram per second, 1 kilogram of fuel. Whether it's 1 kilogram per second or 1 kilogram doesn't matter because we are looking for this flow rate in response to this one. So, meaning you can actually directly use the number of mole from 3. So, from 3 here, from 3 meaning, yeah, the case where we have deficiency of air, right? Meaning the one, yeah, right here. So, first thing you can find here is what is, so let's say we look for what is the total number of moles. Of product. You want to say per second also can, because since we need to find the flow rate, right? So why do I want to find this again? So here, you need to remember one thing. When you are looking at this product, we are talking about dry analysis again. But so meaning that total number of moles, we did not include water. So now you need to include the water term for the total. So now this will be the same thing, but you plus water as well. So for every kg of fuel that you consume, you will get this amount of mole for the product. So why is it important to find the amount of mole for a product? We are looking for volume flow rate here, right? And you are given pressure, you are given temperature, so you can use PV equals to NRT. So everything is given here. From here you can get the volume. So what is the volume flow rate? So in a way you can just say this is dot also lah. So we can say that this is the number of mole per second. It's actually number of mole for every kg. But I think ultimately we are saying because you just need to add line term in and you divide it to get the same. Okay, so of course we use the mole version because that will be the easiest since you can use the universal mark, then you don't need to worry about the composition. So T will be absolute temperature 110 plus 273 and pressure 101.3 kilopascal. So this one your answer will be approximately 15.6 essays per second for every 1 kg per second of fuel.
直接过去那个风那边。
然后还是买了买炮，boom。因为你买那个什么100 shot 这样，不要这样放啊。他讲 OK，let's move on to the question。这个是 O2 还是 D2？
No D2, O2 罢了。
Because the thing is,
By
there are
outside.
too many people over there. So actually, if you want, if it is easier to understand, you can just ignore the second.
Bio bisexual.
Yeah. But if you run the 1 kilogram of fuel, right, then actually the molecule also cannot be the second. So that's why I think it's one of the disadvantages in this case. Don't take it. Okay, we quickly look at problem 5. Tomorrow we will discuss more. Problem 5 is a new version in a way, but it is also quite quick one. So look at problem 5. Okay, so once again we will have ultimate analysis. So of a control, actually same thing like this one. Exactly the same. Yes. But this time you are given the product rather than, so yeah, like I said, if you, okay, this one not really efficiency also. This is success. So now, so what is this question? Yeah, so actually this is the same question but kebalik only. So you do have the answer.
Semua yang
So you do know the idea. But this question does give you one thing where, now it does show you that if without, so how should I say, you can actually get the air fuel ratio without doing the theoretical. So it's just a bit different thing. Because like previously when I mentioned, I told you if they tell you you have like 20% access, then you must find for metric first. Because you don't know what is the initial one. So like in this case, right, let's say you do not know what is the theoretical air, you can actually still solve. Because we just quickly write the equation out. Because we don't have enough. And we don't have enough time for the next question also, because that one is a bit more complicated. So now, like in this case, right, the initial part of the equation is exactly the same. We do not know how much air we have. But we know that at the product we have CO2 and some O2, basically that. So don't forget that H2O should always be there, otherwise you'll change the role. So here we know this is excess A. And so H2O we in a way, yes, it's still the same. So this is 0.0725, and then plus some O2, let's call this X. So in this case, actually, O2 you can find easily. So either you, no, there's no either, we still have balance. So you can just balance O in this case. So then, so O will be 4x plus 0.0725 plus 2 0.07125 equals to 2A. Correct. So you actually will have, yes, and then if you look at the N2, then N2 also just variable. So like in this case, you have 2 equations but 3 variables, so not enough. But obviously, of course, the question does give you information. You know the dry product of the CO2 is 40%. So meaning YCO2 is equals to 0.14, which is equals to 0.07125 over 0.07125 plus X plus W. And we can, now we have 3 equations. So now you have 3 variables, 3 equations. Technically, you don't have to solve all. Because what we are looking for here is, what are we looking for? We're actually looking for A. Yeah, actually you need to find A because you want NU ratio. That's all. We are not actually looking for X and W. So, because the question asks for NU ratio and also theoretical A. Theoretical A, you have the answer previously, yeah, so we will do that. So so here, you just sub this in here, you sub this in here, you will be able to get the A value. So the A value here would be 0.1145. Then NU ratio is simply 0.1145, then as usual 4.76, 29, this should give you 15.81 kilogram of A over 1 kilogram of fuel. So the theoretical A you can get from the previous question, same way of doing. You technically cannot get theoretical A from here because you still have to assume complete combustion with no excess A to get that. Here is just moments basically. The more complicated one will probably in the next question you will see again. Because the one a bit longer, that's why I don't want to discuss that just now. So I decided to do this continuing. More we can discuss. You balance up, C and C. How you get from the first one? How I get from the first one? Previous question. It's the exact same view from previous question. So I just take the value from previous question. But rarely we go much. But for me, I because you don't find okay, you don't like to remember the otherwise, whatever you do for that, just use it will so we just find value normally, so it's the easiest one. But no equation because of that. Because there's otherwise nothing to do already. So that chapter in a way is the easiest.
But revision after before next week test.
Tomorrow only you finish this chapter, then revision no more.
Revision for previous chapters.